How can a plane fly against gravity? In fact, its weight can reach hundreds of tons. In this video, we will dissect completely what makes a plane fly. In a plane, there is the acceleration force to make the plane move forward. And there is a lifting force to make the plane lift off the ground. These two forces make the plane able to fly from one point to another. Well, this lifting force is apparently influenced by its speed. The speed of the plane, it is obtained from the jet engine installed under the wings of the plane. While the lift force, where does it come from? It turns out, this lift force is obtained from the wings of the plane. The principle uses Bernoulli's law. I won't go into too much detail about the formula or laws of physics. In essence, Bernoulli's law discusses the relationship between speed and air pressure. So, according to Bernoulli, airspeed is inversely proportional to its pressure. This means that when the air flows faster, the pressure will be lower. Now, how can this be applied to an airplane? So, to create lift, the pressure in the area above an object must be smaller than the area below it. Even though there is gravity, if the pressure difference between the upper and lower areas is large enough, it can lift the object. Based on Bernoulli's law, pressure can be made different by differentiating the speed of airflow on the top and bottom sides of the object. In this case, because we want lift, it means the speed of airflow on the top side must be faster than the bottom side. The problem is, the airflow is constant on the surface of the object, both on the top and bottom sides. How do you make the top flow faster? That can be done by extending the area in contact with the air. So, if the shape of the surface is like this, meaning the top and bottom are the same, then the airflow passing through the top has the same speed as the bottom. But if the top is made slightly curved, it will extend the area in contact with the air. Because the air flowing on this object is constant, but because the distance traveled on the upper side is further, the air will move faster when passing through the curved area. As a result, the pressure on the upper side becomes lower than the lower side. Well, this is what causes lift. The design of the plane is like the illustration above. So the plane's wings, when seen from a distance, are indeed flat. In fact, the surface of the plane's wings is slightly curved at the top. With this design, when the plane is moving, the surface of the wing will hit the air. Well, the Bernoulli effect that we discussed earlier will appear, which keeps the plane flying in the air. Well, Bernoulli's law answers why the plane can stay in the air. So this happens because the plane is moving forward at high speed. The movement makes the plane's wings hit the air. The effect is that air currents appear on the surface of the plane's wings. The curved design of the airplane wing on the upper side creates the Bernoulli effect that keeps the plane in the air. However, Bernoulli's law is not what affects the plane when it takes off. There is something called flight control surface. This is a mechanism to regulate the aircraft to go up or down, or roll right and left, or rotate. Bernoulli's principle works when the aircraft is in the air. By maintaining the speed at a certain point, the aircraft will remain at its height, while flight control surfaces are used for maneuvering, and this uses the principles of aerodynamics. Aerodynamics explains the reaction between the angle of the airflow. For example, when the airflow direction is horizontal like this, then the object will remain in its position. But if we rotate the object, then the angle of contact with the flowing air will also change. This will cause the pressure on one side to be greater, so that the object can be pressed up or down depending on its angle of contact with the air. In an airplane, once again, the air is constant. The plane is the one that moves. Well, the plane has 3 flight control surfaces. First, the elevator. This is used to raise or lower the nose of the aircraft. The second is the rudder. Its function is to make the aircraft able to rotate on a vertical line. The third is the aileron. This is used to make the plane able to roll right and left. Now let's talk about the elevator. When the elevator is straight, the air flows without any resistance. However, when the elevator is bent upwards, it will press on the top side, so there is downward pressure. This causes the tail to go down and the nose to go up. Because the plane is tilted upwards, the surface of the wing is tilted like this. This position also changes the angle of contact with the air. In response, the air will press more on the area under the wing, so that the pressure under the wing is greater, and this makes the plane can take off. That's the animation of how a plane can fly into the air. Hopefully, it can increase our knowledge.